This is 7.4, part 4. So we had just finished off finding the angle using our inverse trig ratios over here. And we found that the angle here was 24.62. I'm just going to round to the nearest whole number to make it 25 degrees, depending on what the question tells you. So let's just say round to whole number. So we found that angle A is equal to 25 degrees. And so now we have to find the measure of angle B. And so there's a few ways you can do this. If I didn't tell you specifically what to do, you could have simply done 180 minus your other two angles, so 25 plus 90 there. So angle B, let's call this angle B over here. And you could have named this something else. You could have called this angle theta, for example. That's a Greek letter. But I'm just going to stick with the letters of the vertices. So that would be equal to, plus 90, minus 90 there. So 65. 65 degrees is what we should get, because when you add all the angles up in a triangle, you get 180. So angle B should be 65. Now, if you did this on a test, and I had the question worded like this, find the angle indicated using the appropriate trig ratio, you wouldn't get your marks because you need to use the appropriate trig ratio. So, and I'm trying to test that skill, which is why I asked you to do that. But you can do this just to verify your work, to see that you're on the right path. So let's try this out. Let's look at angle B. Angle B, I'm going to erase the labels I made for angle A right now. Or actually, I'll leave them there so you can compare, but I'll just do it in a different color. So this is still the hypotenuse no matter what. But let's do this in green. So for angle B, this side here, the 5 centimeters for angle B, I'll make this in green, is the adjacent side now. The adjacent side. So we have the adjacent side and a hypotenuse. If we have adjacent and hypotenuse, we have cot. So we know that cos of angle B is equal to adjacent over hypotenuse. So we know that cos of angle B is equal to 5 over 12. And so to find angle B, we do the inverse cos of 5 over 12. And we get, so I'm going to do my second function cos, brackets, 5. You can do your fraction button or just divide it by 12, close the brackets. And then you get 65.37. But I'm going to round to the whole angle, so about 65. 65 degrees would be angle B. So angle B is equal to 65 degrees, which matches what we did over here to verify our work. And we had to use a cos function. So notice again, you choose your angle, you see how the sides relate, and then you choose one of these ones, so, ka, or toa, to solve for the for what you're being asked for. So we'll do this last question here, solving a triangle. I already did one above to show you how that works, so you could actually probably just try this on your own and verify with me to see that you have done everything correctly. So we're solving for the triangle. We're basically looking for everything here. So I'm going to start off by labeling sides. I'm going to start off by just labeling things. Label all. So this is called side C, which is my hypotenuse all the time. It's lowercase c because it's opposite of angle C. This is vertex B, so this is side B over here, 15 centimeters, and angle B is 75. This is vertex A, so this is angle A over here. And then the opposite side of that angle would be, of that vertex would be side A over here. And so let's plan here. We have a few things we need to find. To solve this triangle, we need to find side C, the hypotenuse. We need to find angle A. And we need to find side A. So to solve our triangle, we're looking for everything that's missing. Little a, little c, angle A. So what I'm going to do is, so this is our second step. And so what I'm going to do is, I'm just going to set some parameters here based on the question. We're going to do angles will be whole numbers. That's how we'll round. I'll usually specify, but if I don't, just round your angles to whole numbers. And then sides will be to 2 decimal places. So I'm going to start off with finding my angle. So let's call this step 3 here. Let's find angle A. So we know that angle A is going to be equal to 180 minus the sum of the 2 other angles, 75 plus 90. Which will be equal to 15 degrees. So we found angle A, and I'm going to go and put that in my diagram. 15 degrees. Let's go and find side A. You might have done a different order than I did, but that's fine. Let's just make sure we have the right answer. So find side A. Let's choose an angle. It doesn't matter what angle we choose. I'm going to choose one that's already given to us, just in case I made a mistake with the first one. So I'm going to choose angle B over here. And so I want to relate A and B together. So A is adjacent to B. A is adjacent to angle B. How does side B relate? Because I need something known here. I need 2 known things and 1 unknown thing. My unknown thing is A. I need 2 known things to help me find A. So in the case of my angle here, A is the adjacent. B over here would be the opposite. So I have the adjacent and the opposite. Let's remember that. So, ka, toa. Opposite and adjacent. I'm using my tan in this case. So I know that tan of angle B is equal to the opposite over adjacent. So tan of 75 is equal to opposite 75 is 15 centimeters over my adjacent side, which is A. We don't know what it is. Now we can solve for it by multiplying both sides by A. Cross that out, we get A tan 75 is equal to 15. And now we can divide both sides by tan 75 to solve for A, to get A alone. And normally I should continue the work below. Oh, I still have some room. Perfect. So I get A is equal to 15 divided by, open brackets, tan, make sure it's in dag, of 75. And I keep 2 decimal places for this, so 4.019, so 4.02 centimeters. 4.02 centimeters. So I can write that here is equal to 4.02 centimeters. So now we found our angle A, and we found our side A, and we approximated, so make sure again you put a little dot on top to show that it was an approximation. So all we really need to find now is side C. And so there's a few different ways you can do that. You could use your theorem. let's just use our trig ratios to practice our trig ratios. So we're going to find, so step 5, find C. And so let's take a look at the angles. We could really use any angle. Let's just use the same angle that we had here, 75, angle 75. C is the hypotenuse. And then let's use the side given to us in the question, just so that in case I made a mistake in any of these, it doesn't carry through in my finding side C. So if I have angle 75, B would be the opposite, and then we have hypotenuse. So opposite over hypotenuse. So sine. So sine of angle B is equal to opposite over hypotenuse. So that means sine of 75 is equal to 15, which is the opposite side over the hypotenuse, which is C. I can multiply both sides by C. And so I get C sine 75, so C multiplied by sine of 75 is equal to 15. I can divide both sides by sine of 75. And I get C is equal to, so let's do 15 divided by open brackets, sine, make sure it's degrees mode, 75, close brackets. I get 15.53. So 15.53 centimeters. Put the little dot there to show an approximation. So 15.53 centimeters, and I found C in the end. So what I usually do is my final answers, I'll put them in a little box like this, and I'll say therefore solved triangle, and I'll put my my answers just to have it nice and organized. So side C is equal to 15.53 centimeters. Side A is equal to 4.02 centimeters, and then angle A is equal to 15 degrees. And there you have it. You could verify side C just to make sure that everything kind of works together. So for example, I could do, so I'm just going to do an extra step. I'm going to do a verifying or double checking if you have time. If you don't have time, don't waste your time doing this. It's really only if you have time near the end. So a squared plus b squared is equal to c squared. So we have 15 squared plus 4.02 squared. We might not get the exact answer because we rounded, but we'll get pretty close if we did all our steps correctly. So we get 225 plus 4.02 squared, 4.02 squared is equal to, so we have 241.16 is equal to c squared, and so c is equal to the square root of 241.16, which is equal to, so let's do square root of that, 15.53. So we get pretty close to what we have to a certain number of decimal places, 15.53 centimeters. So it was a way to verify using our theorem to see if we were on the right path. So it's a great way to verify your work. There's many ways to solve a triangle, but since we're using trig ratios, let's focus on that when we can. It's like a puzzle. You just need to find more and more pieces, and the more pieces you find, the more parts you can find of that triangle. So those were our primary trig ratios, sine, cosine, and tangent. We use them when we have our right-angled triangles. We learned how to use the primary trig ratios to find, and also their inverse functions to find angles and sides within triangles. Make sure you follow form properly when you're doing communication. Make sure your calculator is in degrees mode, and please be sure to watch that tutorial on the calculator.